The debrief: hypersonic bomber emerges as office's next goal after NGAD. Introduction. In a groundbreaking announcement on February 13, 2025, the Defense Advanced Research Projects Agency DARPA revealed its ambitious plan to develop a large hypersonic bomber prototype. This initiative is being led by the Aerospace Projects Office (APO), marking a significant strategic shift following the progress made in the Next Generation Air Dominance (NGAD) program. The move reflects the U.S. military's increasing focus on advanced aerial combat capabilities capable of outpacing adversary defenses in an evolving global security landscape. Project announcement. The announcement came to light through Aviation Week, which reported that the APO, known for its secretive nature, is embarking on this innovative project. Unlike other DARPA divisions, the APO maintains a low profile, with its existence notably absent from the official DARPA website. This discretion adds an aura of intrigue regarding the office's objectives and the specifics of the hypersonic bomber's design. Significance of hypersonic technology. Hypersonic technology, characterized by speeds exceeding Mach 5, represents a revolutionary advancement in military aviation. The development of such a bomber is not merely a technical endeavor, it signifies a strategic response to the increasing capabilities of potential adversaries. As nations around the world enhance their military technologies, the U.S. aims to maintain its technological edge. Technical specifications. While detailed specifications of the hypersonic bomber remain classified, there are indications that the design will incorporate advanced propulsion systems. The Lockheed Martin State Route 72 concept, which utilizes a turbine-based combined cycle propulsion system, serves as a reference point for the expected technological framework of the new bomber. This propulsion system is designed to optimize performance across various flight regimes, enhancing speed and operational efficiency. Strategic importance. The Hypersonic Bomber Initiative aligns with the broader strategy of the U.S. military to develop next-generation weapons systems that can effectively penetrate and outpace existing defense mechanisms. As global military dynamics evolve, the capability to deliver payloads at hypersonic speeds could drastically alter the landscape of aerial warfare. The project underscores an urgent need for innovative solutions to counter emerging threats and ensure national security. Community interest and reactions. The announcement of the hypersonic bomber project has elicited significant interest within the defense community and beyond. Various discussions and interactions on social media platforms indicate a mix of enthusiasm and cautious optimism regarding the potential implications of this project. Analysts and military experts are closely monitoring developments, recognizing that this initiative could redefine aerial combat paradigms. Differences between sources. While both Aviation Week and social media outlets reported on the hypersonic bomber project, the former provided a comprehensive analysis of DARPA's strategic objectives and the technical underpinnings of the initiative. In contrast, social media posts primarily served as brief announcements, lacking the depth and context present in the more detailed articles. This discrepancy highlights the importance of thorough reporting in understanding the full implications of defense initiatives. Timeline of events. February 13, 2025, Aviation Week publishes the announcement regarding the hypersonic bomber project, shedding light on the objectives of the Aerospace Projects Office. February 14, 2025, additional discussions and analyses emerge, further exploring the implications and potential impact of the hypersonic bomber within the defense sector. Conclusion. The emergence of the hypersonic bomber as the next goal for DARPA's Aerospace Projects Office represents a significant milestone in military aviation. This initiative not only continues the advancements seen in the NGAD program but also responds to the rapidly changing landscape of global military capabilities. As the U.S. commits to maintaining its technological superiority in aerial combat, the implications of this hypersonic bomber initiative will be closely scrutinized by defense experts and analysts alike. The project promises to be a pivotal development in the future of warfare with potential ramifications for both national security and international relations. The announcement regarding the development of a large hypersonic bomber prototype by DARPA's Aerospace Projects Office (APO) unveils counterintuitive perspectives about military technology advancements. 1. Secrecy and transparency paradox. While one might presume that significant military projects would be prominently publicized to demonstrate capability and innovation, the opposite is true for the APO. Its low profile even within DARPA suggests an operational strategy that thrives on secrecy. This counters the conventional notion that visibility equates to strength. Instead, the APO's discretion may serve as a tactical advantage, allowing it to operate without scrutiny and potentially outpace adversaries in the hypersonic technology race. 2. Technological evolution versus historical precedent. The hypersonic bomber project builds upon advancements seen in the Next Generation Air Dominance (NGAD) program, yet it diverges from typical military development timelines. Historically, military innovations have taken decades to transition from concept to operational capability. The rapid push towards hypersonic technologies, however, suggests a sense of urgency that may stem from perceived threats, marking a departure from traditional military development cycles where incremental improvements were the norm. 3. Community engagement and skepticism. The mixed reactions from the defense community highlight a counterintuitive relationship between enthusiasm and skepticism. While there is excitement about the potential of hypersonic capabilities to transform aerial warfare, there is also caution regarding the feasibility and practicality of such technologies. This duality indicates a deeper understanding among defense professionals that while innovation is critical, the challenges of implementation, budget constraints, and potential technological setbacks must also be acknowledged. 4. Strategic shift in military doctrine. The focus on hypersonic bombers signals a counterintuitive shift in military doctrine from traditional air superiority to a more nuanced approach that emphasizes speed and surprise. This transition raises questions about the future of aerial combat, suggesting that dominance may increasingly rely on the ability to strike quickly and evade detection rather than sheer numbers of aircraft or overwhelming firepower. 5. Public perception versus military reality. The announcement has sparked considerable interest on social media, which contrasts with the typically reserved nature of military communications. This highlights a disconnect between public perception of military projects as transparent and accessible versus the reality of their development processes, which are often shrouded in secrecy. The enthusiasm expressed online may not accurately reflect the complexities and challenges faced by the military in realizing such ambitious projects. In summary, the emergence of a hypersonic bomber prototype as a goal for DARPA's Aerospace Projects Office illustrates several counterintuitive elements regarding secrecy in military projects, the rapid pace of technological development, and the shifting paradigms of military strategy and public engagement. These dynamics reflect a complex interplay between innovation, operational secrecy, and strategic military needs, challenging traditional views on how military advancements are perceived and implemented. The announcement of DARPA's intention to develop a hypersonic bomber prototype spearheaded by the Aerospace Projects Office (APO) represents a significant milestone in military aviation and strategic defense capabilities. While the mainstream media and defense analysts have highlighted various aspects of this initiative, several critical elements may be overlooked by the general audience. Yet they hold substantial significance for understanding the broader implications of this program. Key aspects often overlooked. 1. Secrecy of the Aerospace Projects Office (APO). The APO's operations are characterized by a high degree of secrecy even compared to other DARPA divisions. This is not merely a matter of operational security, it reflects a strategic choice that influences how military projects are developed and ultimately revealed to the public and potential adversaries. The absence of information on the DARPA website about the APO raises questions about the nature of the projects it undertakes and the specific goals it aims to achieve. This level of confidentiality can lead to a technological edge, as adversaries may be unaware of the capabilities being developed until they are deployed. 2. Technological ambiguity. While the potential use of advanced propulsion technologies such as the turbine-based combined cycle system akin to Lockheed Martin's State Route 72 is mentioned, the specifics of the hypersonic bomber's design remain undisclosed. This ambiguity is significant because it indicates that the U.S. military is likely pursuing cutting-edge technologies that could redefine aerial combat. The lack of detailed information allows for speculation and could serve as a psychological deterrent against adversaries who may be compelled to invest heavily in countermeasures without a clear understanding of the capabilities being developed. 3. Broader strategic context. The hypersonic bomber project is not an isolated initiative but part of a larger trend within the U.S. military to enhance its deterrent capabilities against near-peer adversaries. The emphasis on hypersonic technologies aligns with ongoing global military advancements where countries are increasingly focusing on speed, reach, and stealth. This context is crucial for understanding why the U.S. seeks to invest in hypersonic capabilities and the potential ramifications for global security dynamics. The shift to hypersonic systems can be seen as a direct response to the growing capabilities of nations like China and Russia, which are also investing heavily in similar technologies. 4. Potential impact on aerial warfare. The introduction of a hypersonic bomber could revolutionize aerial warfare by enabling rapid strikes at distances previously thought unattainable. This capability could change the calculus of military engagement as the timeframe for response to threats would significantly diminish. The implications for military strategy are profound, as commanders could potentially strike targets with little warning, altering the balance of power in conflict scenarios. The ability to deliver ordnance at hypersonic speeds could also challenge existing missile defense systems, which may be ill-equipped to respond to such threats. 5. Community reactions and future outlook. The immediate reaction from the defense community, as evidenced by social media discussions, underscores a mix of excitement and skepticism regarding the feasibility and potential of the hypersonic bomber initiative. This dialogue is significant as it reflects broader concerns about the U.S. military's ability to maintain technological superiority amidst rapid advancements by adversaries. The community's reactions may influence public discourse and policy decisions related to defense spending and prioritization of military research and development. 6. Historical precedent. The hypersonic bomber project can be contextualized within the historical trajectory of military aviation advancements. Historically, breakthroughs in aerial technologies have often led to significant shifts in military strategy and capabilities. Drawing parallels to the development of stealth technologies in the 1980s and 1990s. The hypersonic bomber could similarly reshape the nature of air warfare if successfully developed and deployed. Understanding this historical context helps in anticipating the long-term implications of such projects on military doctrines and international relations. Significance of overlooked content. The facets of secrecy surrounding the APO, the ambiguity of technological details, and the broader strategic context of the hypersonic bomber project are significant not only for military planners but also for policymakers and analysts monitoring global defense trends. These elements contribute to a nuanced understanding of how military capabilities are evolving in response to geopolitical pressures. Moreover, the project highlights the ongoing arms race in hypersonic technologies, underscoring the urgency for the U.S. to maintain its competitive edge. The potential impact on strategic deterrence and military engagement cannot be overstated. Advancements in hypersonic capabilities may redefine the rules of engagement, influence alliance dynamics, and shape the future of international security. In conclusion, while the DARPA announcement regarding the hypersonic bomber has generated interest, the deeper implications of secrecy, technological uncertainty, and strategic relevance warrant closer examination. These considerations are essential for grasping the potential changes in military strategy and international relations that may arise from this initiative. As the project progresses, it will be crucial for analysts and policymakers to keep an eye on developments and their broader ramifications for global security. 1. Project announcement and secrecy. The announcement of DARPA's intention to develop a hypersonic bomber prototype by the Aerospace Projects Office (APO) is noteworthy due to the office's high level of secrecy, which exceeds that of other DARPA divisions. This secrecy raises questions about the project's specific strategic objectives and potential capabilities. The APO's low profile, evidenced by its absence from the DARPA website, adds an element of intrigue and underscores the importance of this initiative within the broader context of U.S. defense strategy. 2. Technical specifications and propulsion technologies. Although specific design details of the hypersonic bomber are not publicly available, the project's potential reliance on advanced propulsion technologies such as those seen in Lockheed Martin's State Route 72 concept is significant. This turbine-based combined cycle propulsion system could enable the bomber to achieve and sustain hypersonic speeds, enhancing its operational effectiveness. The exploration of such innovative technologies is crucial in understanding the potential capabilities of the new bomber and its role in future aerial combat scenarios. 3. Strategic importance of hypersonic capabilities. The development of a hypersonic bomber aligns with the U.S. military's strategic emphasis on advanced weapons systems that can effectively counter adversary defenses. This shift towards hypersonic technology reflects a broader trend in modern warfare, where speed and surprise are critical. As adversaries develop their own hypersonic capabilities, the U.S. commitment to maintaining technological superiority through projects like this underscores the changing landscape of global military dynamics and the need for responsive defense strategies. For community interest and reactions, the announcement has generated significant interest within the defense community, as shown by social media interactions and discussions. This enthusiasm indicates a recognition of the potential impact of the hypersonic bomber on aerial warfare and military operations. However, the mixed reactions also suggest a level of cautious optimism, with experts and analysts likely to scrutinize the implications of this initiative for future warfare defense budgets and the overall U.S. military strategy. The community's engagement highlights the importance of such projects in shaping public and institutional perceptions of national security priorities. 1. The Manhattan Project 1942–1946. This was a secretive research and development project during World War II led by the United States with support from the United Kingdom and Canada. Its goal was to develop the first nuclear weapons. The project mobilized some of the greatest scientific minds of the era, including Robert Oppenheimer and Enrico Fermi. The culmination of the Manhattan Project was the successful detonation of the first atomic bomb in July 1945, followed by bombings of Hiroshima and Nagasaki, which significantly contributed to the end of World War II and ushered in the nuclear age. 2. The Apollo Program 1961–1972, initiated by NASA. The Apollo program aimed to land humans on the Moon and bring them safely back to Earth. Following the Soviet Union's success with the first human in space, the U.S. committed to achieving this goal, culminating in the historic Apollo 11 mission in July 1969, when astronauts Neil Armstrong and Edwin Buzz Aldrin became the first humans to walk on the lunar surface. The program not only showcased advanced technology and engineering capabilities but also marked a significant achievement in the space race during the Cold War era. 3. The F-117 Nighthawk Stealth Fighter Program 1975–1989. Developed by Lockheed Martin, the F-117 Nighthawk was the first operational aircraft designed around stealth technology. Its development began in the 1970s under a highly classified program aiming to create an aircraft that could penetrate enemy defenses undetected. The F-117 made its combat debut during the Gulf War in 1991, demonstrating the effectiveness of stealth technology in modern warfare and significantly influencing the design of future military aircraft. Future outlook: the hypersonic bomber and its implications for military aviation. As the Defense Advanced Research Projects Agency DARPA embarks on the development of a hypersonic bomber prototype, the implications for military aviation and global defense strategies are significant. This initiative not only represents a technological leap but also a strategic pivot in the context of evolving geopolitical threats. Here we explore the potential future developments stemming from this project, considering technological advancements, operational capabilities, and the broader defense landscape. 1. Technological advancements. The hypersonic bomber project will likely drive innovations in several key areas. Propulsion systems. Building on concepts like Lockheed Martin's State Route 72, advancements in turbine-based combined cycle propulsion systems could enhance speed and efficiency, allowing the bomber to operate at speeds exceeding Mach 5. This capability would require breakthroughs in materials science to withstand extreme temperatures and pressures. Stealth and evasion technologies. The incorporation of advanced stealth features will be crucial. As adversaries develop better detection systems, the hypersonic bomber must integrate cutting-edge radar-absorbing materials and designs that minimize its radar signature, ensuring it remains undetectable during missions. Autonomy and artificial intelligence. Future bombers will likely incorporate sophisticated AI systems for navigation, targeting, and threat assessment. This autonomy could enable the aircraft to operate in contested environments, reducing the risk to human pilots. 2. Operational capabilities. The introduction of a hypersonic bomber could redefine aerial combat and strategic deterrence. Rapid response and global reach. The speed of hypersonic bombers would allow for rapid deployment to any global hotspot, fundamentally changing the response time to emerging threats. This capability would enhance the U.S. military's ability to project power and deter adversaries. Enhanced strike capabilities. The ability to strike targets at hypersonic speeds could disrupt enemy defensive systems, making it challenging for adversaries to respond effectively. This could pave the way for more aggressive military strategies and preemptive strikes. Integration with existing platforms. The hypersonic bomber will likely complement existing platforms within the next-generation air dominance NGAD framework, creating a multi-layered approach to air superiority. This integration could involve coordination with fighter jets, drones, and other surveillance systems, enhancing overall mission effectiveness. 3. Geopolitical implications. The emergence of hypersonic capabilities will inevitably alter the global defense landscape. Arms race dynamics. Other nations are likely to accelerate their own hypersonic programs in response to the U.S. initiative. Countries such as China and Russia have already been investing heavily in hypersonic technologies, thus a new arms race may emerge focusing on speed and precision. Strategic partnerships. The U.S. may seek to strengthen alliances and partnerships to counterbalance adversarial advancements in hypersonic technology. Collaborative development and joint exercises with allies could enhance collective defense capabilities. International norms and treaties. As hypersonic weapons blur traditional lines of warfare, there may be calls for new international norms for treaties governing their use. The challenge will be to establish agreements that prevent escalation while allowing for technological advancements. 4. Economic and industrial impact. The development of a hypersonic bomber will have significant implications for the defense industry. Investment in R&D. Increased funding for research and development will spur innovation across various sectors, including aerospace materials science and propulsion technologies. This could lead to breakthroughs with applications beyond military use, benefiting civilian industries as well. Job creation and skills development. The focus on advanced military technologies will require a highly skilled workforce. This could lead to job creation in engineering, manufacturing, and research sectors, fostering a new generation of professionals in cutting-edge fields. 5. Ethical and societal considerations. As hypersonic technology advances, ethical considerations will become increasingly important. Civilian safety and collateral damage. The speed and precision of hypersonic weapons raise concerns about potential collateral damage. Ensuring accountability and minimizing civilian casualties will be crucial in the operational deployment of such systems. Public perception and acceptance. As hypersonic capabilities become more prominent, public opinion may shift regarding military spending and the use of advanced weaponry. Open dialogues about military technology and its implications for society will be essential. Conclusion. The Hypersonic Bomber Initiative by DARPA represents a pivotal moment in military aviation and defense strategy. As technology advances, operational capabilities expand, and geopolitical dynamics shift, the implications of hypersonic warfare will be profound. Stakeholders across the defense sector must navigate these complexities, balancing military innovation with ethical considerations and international stability. The future of aerial combat is set to be redefined, and the world will be closely watching how these developments unfold.